packet, find problem 3.3, where we left off. And there's a little story about an overnight field trip to a nature center. It costs $750 to rent the center, and the students must pay a fee. It's $3 per student if all 250 go, but it's unlikely that all the students can go, so they want to find the cost per student for any number of students. So essentially, no matter how many people go, they have to get the $750. So let's think about this for a moment. If we make a little table. If one student goes, very unlikely, very weird, but it is part of our data, they would pay the whole $750. Now, do you think it's going to be smart to count by ones? Because at the very end here, $750, or 750 students go, it would be $1 per student. But there's only 250, so this whole problem is going to cap off at 250. And we already know if 250 students go, it would be $3 per person. And 250 times 3 is 750. So you could put in a 2 if you want. If 2 people go, it will be $375 each. You could count by a bigger number, like if 5 people go. If you have $750 you must get to find this answer, we're doing 750 divided by 5, and that would give 150. So you could go to 10 next. 750 divided by 10 is 75, but maybe we could go to some even bigger numbers, like 25. We could even count by 25s. 25 would give 30. 50 would give 15. 75 would give 10. 100 would give 7.5. 125 would give 6. 150 would give 5. That's good enough, I guess. So the equation is x times y is always equal to 750. Instead of x and y's, you might want to use the words. So students times cost has to equal $750. You would solve this for y. So if you divide by students, the cost is found by doing 750 divided by the students. And then because the equation is a letter in the denominator, we know this is going to be one of those hyperbolic curves. So we need to label the axis, and we can put $750 trip as a title, or whatever title you think is fitting. And then we're going to start plotting 1. So 1 is right here, maybe, like even closer than that. That looks more like 5. So 1 is 750. Remember, this does not cross the axis. In fact, 0 is not even an option. There's that thing called an asymptote. That's that dotted line in which this is never, ever going to touch. So my marker is a little bit fat, and it looks like it's touching, but it is not touching the axis. So 750 is as close as you can get to the axis, but it's not touching it. That still looks like it's touching it, but it's not. All right, so 2, super close again, drops all the way to 375. So again, this is not That looks better, not touching the axis. And then 5 was 150, so we're still way over here. See how much we've dropped just from 1 to 2 to 5? So this super steep drops right away. Then it's going to kind of level off. So 10 gives 75. We're still in this first box. That's why these numbers are really important. 25 gives 30. 50 gives 15. 75 gives 10. 100 gives 7.5. Oops. 125 gives 6. 150 gives 5. 250 gives 3. So again, there's an asymptote. It's this, nothing is ever going to touch this axis. You're never going to get 0 as an answer. So these dots, it's kind of hard not to make them touch, but they don't. They are above that dotted line, and that's really hard to show you on this board. So this never crosses that dotted line. I need like a fine tip something. And this never crosses this dotted line. It's flat, never crosses the axis. It will never be equal to 0. So as x increases, y decreases less and less. All right, so 10 to 20, we're going to find the slope between just those 2 points. Now, the slope completely changes every single time. There's no constant slope with a hyperbola whatsoever. So 10 gives 75, and 20 gives 37.5. Again, if you're having trouble understanding, to get this answer, you would do 750 divided by 20. And that's how you get the 37.5. Same with 10. 750 divided by 10 is how you get the 75. Because remember, x times y is always equal to 750. All right, so these are your two ordered pairs, and you're going to find your slope. So you're going to drop that little line. And 75 minus 37.5 is 37.5. And 10 minus 20 is negative 10. So the slope just between these two sections is negative 3.75. So now we're going to find the slope between 100 and 110. Do you think it's going to be more, or do you think it's going to be less? Since it gets flatter and flatter, it's probably going to be a smaller slope, a smaller change. So 100 gives 7.5 as the y, it's x then y. And 110, when you do 750 divided by 110, you get 6.8182. So to find the slope between these 2 points, you would do 75 minus 6.8182. All divided by 100 minus 110. So 7.5 minus 6.8182, I'm using a calculator here, is 0.6818 divided by negative 10. So the slope here is negative 0.06818. That's even smaller. As you go up, you think it gets even smaller? It does. So when you plug 200 in, you get 3.75. And when you plug 210 in, 750 divided by 210 is 3.5714. So 3.75 minus 3.5714 is 0.1786. And then you have 200, I'm just writing this right here, minus 210, which is negative 10. So this slope is negative 0.01786. So this is just showing that you are losing less and less and less and less and less every single time your x increases. So the slope is not the same. It is less and less. So that's how you know it's not linear. Okay, I think I'm going to skip this chunk. Hopefully you're not too sad. So we're on to a totally different question. And it says the science teachers decide to charge $5 per student for the trip. They'll use any extra money to buy science equipment for the school. So your equation is going to be, so the amount the teacher will collect and the students that go on the trip. So money, it says to use A, so let's shove an A here, is equal to $5 times the number of students. And it's asking to use an N here. So amount equals 5N. Amount equals 5N. We're going to sketch a graph of this. These equations, all three of them, 1, 2, 3, are the exact same. For me, the last one makes the most sense. You can use whatever one you want. The problem's asking you to use this. If you choose to use y as an x, you need to define your variable. So you would need to put that y is cost, or the money the teacher's going to collect, and x is the number of students that go on the trip. So if 0 go, 0 money is collected. Now, there's 250 students, so to count by 1 is probably not the best choice. So maybe count by something bigger, 10s, 20s. So if you plug 10 in, you would get 50 because 5 times 10 is 50. If you plug 20 in, you would get 100. 30 would give you 150. 40 would give you 200. 50 would give you 250. 60 would give you 300. So as you go up by 10 in the x, this is your run, you're going up by 50 in the y. This is your rise. And if you do the rise divided by the run, you still get 5, which is the slope that we already know. So to sketch a graph of this, in the x-axis, you're most likely going to count by 10s or 20s, whatever you decided to count by on your table. We know it's linear because we're in the form y equals mx plus b, so you only need a couple points. In the y, it's probably going to be most helpful to count by at least 50s. That's what we're going up by if you count by 10s in the x. So 0 gives 0, 10 is 50, 20 is 100, 30 is 150, 40 is 200, 50 is 250, 60 I have in the x, I'll throw a 300 up there. So it's this lovely linear pattern. Now, would it make sense to connect the dots? Yeah, because you can have one student go. You can't have a half, but the numbers in between these do work. There should be like 10 little tick marks. And if you did want to find slope, just given this lovely graph, when you drop your triangle, it appears to be one space and one space. But you need to remember, this is counting by 50. And this down here is counting by 10. So just really make sure you're seeing what you're counting by. And then again, 50 divided by 10 is a slope of 5. And 0 is your B. So is the linear relationship inverse? And it's not. It's just a straight line. As x goes up, y is going up. So the opposite thing is not happening. That's probably good enough. All right. That's like the grand finale of Investigation 3. We'll move on to Investigation 4 next time we meet. Have a great evening.